So good night. Yours truly, Professor Dr. Dolphy Gilpin, taking a little break, and we are returning now with a continuation of introduction to the elements of the periodic table. And we are now doing random elements after establishing consecutive order according to the period 1 to 20. So here we have nickel at atomic number 28. Nickel at atomic number 28, and let's try to extract it from our little pack here. It's going to be much more difficult as the pack is now jumbled, and we're going to be using gallium, so let's take out gallium as well. And we're going to be also using vanadium. So let's take out gallium, vanadium, and nickel. Let's see, moscovium, manganese, bromine, copper, iron, gold, ytterbium, moscovium, Mc. We're looking for, this is copperusium, oleum, gadolium, krypton, and we're looking for xenon, niobium, and we're looking for Ni, erbium, osmium, organesum, neonium, NH, and let's see, and technetium, carbon, phosphorus, oxygen, hydrogen, oxygen again, helium, lithium, magnesium, iodine, chlorine, mercury, silver, helium again, lanthanum, nitrogen, sodium, phosphorus, and aluminum. Wow. It's all jumbled up now, so it's taking a good while for us to fluorine, argon, nickel. So we're going to be using nickel and gallium. We put those two there, and also vanadium, but we'll look at vanadium at another time. Okay, nickel. Atomic number 28, atomic mass of 58.69, noble gas configuration AR 3d84s2, nickel powder reacts with oxygen at 400 degrees centigrade and giving nickel oxide. Now in some commercial uses, we have the process, we have nickel oxide is made by heating nickel powder with water at about 1000 degrees centigrade to give nickel oxide. Now the rate of the reaction can be increased by the addition of nickel oxide powder. Now nickel plus 2 hydrochloric acid will give you nickel 2 chloride plus hydrogen. And notice we have nickel 2 and we have nickel 1 chloride and nickel 2 chloride. Now nickel 2 chloride is produced by dissolving nickel or nickel oxide in hydrochloric acid. Now when ammonia is added to a solid containing nickel and nickel oxide, nickel hydroxide is formed. Yeah, that's when you add a solid, the nickel solid, and nickel oxide. To ammonia, then nickel hydroxide is formed. So you have nickel also plus sulfuric acid will give you nickel sulfate and hydrogen. That looks like a displacement. It seems like a displacement reaction, like what magnesium with hydrochloric acid and hydrochloric acid will do in the alkaline earth metal and also the alkaline metal. Now nickel is an hard silver white metal which can cause irritation to the skin, and it can cause damage to the lungs, kidney, and to the stomach. So there we have an introduction to nickel, and what we want to do next is to give you some reactions of nickel. You know, reactions with like the halogen family, so it will react with the halogen family, so it will react with acids, so it will react with other popular compounds. But that will leave for a second experiment on nickel. And here we have nickel, let's see what we have here. Here we have nickel in the periodic table. You are part of the periodic table at atomic number 28. Ni 28, and it's 50.69, I believe, for the atomic mass. 28 and that. I notice it is in group 10 with PD and PT. What's that? One of them is platinum, probably palladium, and osmium. That's the group it is in there. That's nickel. So it has to be 56.693 is the atomic mass. And we can sometimes look at the atomic number and know that it most of the time is double and past double. So if the atomic number is 28, then 28 double would be 56. So it's really 56.693, the atomic mass. And notice that, though, the atomic mass, the difference between the atomic mass and the atomic weight is that the atomic weight is the average weight of the isotopes or the isotopic weights of the element. Yeah, that's the difference between now the atomic mass and the atomic weight. The atomic weight is the average weight of the isotopes. You know, you're taking all the isotopes together and also consider their abundance in nature. And by that, getting those weighted averages of the isotopes with consideration of the abundance in nature, you get the atomic weight. Normal mass and weight, that is in Newtonian chemistry and physics. The difference is just that the weight depends on gravity. So that, you know, height depends on gravity and different position according to the equator depends, the gravity magnitude is different, so that the weights would be different at different geographical position in the earth, but the mass remains the same. So that's the difference between mass and weight, and atomic mass and atomic weight. The atomic weights are the average weights of the isotope or the isotopic weights, taking in consideration their abundance in nature.